A new generation of ultra-wideband products is entering the market. That's why we at Rohde and Schwarz have enhanced our CMP200 radio communication tester with a UWB testing functionality, making ultra-precise wireless UWB measurements possible. But how does the technology work? Ultra-wideband is a radio technology that uses a very low energy level for short-range communications using short signal pulses with a wide bandwidth. The ultra-wideband technology was first used in 2002, mainly for specific industry applications. Over the years, the evolution of its standards enabled more and more use cases. And the new Z amendment was further improving in multiple aspects and adding a secure ranging functionality. This allowed new use cases for smartphones, wearables, tags, car access, and more. Next to secure low-power communication, the key use case of the ultra-wideband technology is precise ranging. While Bluetooth LE ranging based on the received signal strength can provide, dependent on the radio conditions, a range precision of a few meters, UWB measures the real-time location with a variant of a few centimeters. The distance between two objects can be calculated based on the time of flight. It is the time the signal needs to pass from initiator to the responder. Here's how it's measured. You take the time a signal needs from device A to B and back. On the way back, device B sends information about its time of reply to device A, so it can calculate the time of flight. Accurate TOF estimation requires time measurement at the analog antenna. Therefore, it is necessary to know the time difference between the antenna and the digital time processing. Because this correction value can vary, it is necessary to calibrate and validate UWB devices. So we have to come up with a smart solution to accurately measure the TOF. By using a coupler as an extension to our CMP, we can exactly measure the time differences and compare with the expected TOF of the test setup. Now we can calculate the time difference and can tune the correction values of the device with a high precision. UWB measurements should ideally be done over the air, and Rohde and Schwarz is your one-stop partner for ultra-precise wireless testing. We provide the full test setup for all your measurement tasks. And here's how it works. The device under test is put in a shielding cube for over-the-air testing. Then a signal is generated by the generator within the CMP200. Through the coupler and a switch, the signal is passed to the antennas. The answering signal from the device follows the same way backwards and is processed by the analyzer within the CMP200. We are supporting both test setups with the device as responder or initiator because the CMP200 can act in both modes as initiator or responder. With our 3 antennas set up in the shielding cube, we can also measure the angle of arrival. The antenna in the middle is placed with a 0-degree orientation to the device and helps calibrating and verifying the time of flight. In combination with the 2 antennas in minus and plus 45 degrees to the device, we can send signals in 3 different angles. Due to the physical offset of the device's antennas, the device measures a phase offset, also called phase difference of arrival, and calculates the angle of arrival. The Smart Channel function divides the tester into multiple sub-instruments, allowing the tester to share its hardware with multiple DUTs. This enables parallel testing of multiple devices and technologies. With this setup, we can perform all cases important for ultra-wideband testing. Ultra-wideband has become an important technology for the present and the future. Whatever use cases you're planning, Rohde and Schwarz is your partner for the most precise UWB testing.